Good evening, Night Owls. This is Dr. Nighttime, and tonight we're going to begin my LTAM course. This is intended to be a standalone video course. You do not need to be enrolled in any sort of college course for this. It's intended to be a standalone course, and it's intended to prepare you, the student, to take exam LTAM. This video will talk about the overview and all the introductory material, as well as the material from Chapter 1. By the way, all chapter numbers that I quote will be from the Dixon, Hardy, and Waters text of Actuarial Models for Life Contingent Risks. So just as an overview, I mentally divide the course into 4 parts. Part 1 talks about the introduction to the basic insurance, or simple insurance arrangements, those being just life insurance and life annuities. So those arrangements and the mathematical tools to properly do calculations regarding them. Part 2 talks about pricing and reserves. That is, if you know what the insurance benefit is supposed to be, how would you price what the monthly premium should be? And then for reserves, once you've had policies in force for a while, how would you determine the amount of money that you need to have in the bank for the company to be expected to meet its liabilities? Part 3 discusses more complex insurance arrangements, typically involving different conditions of death or different number of people, and then pensions are also in there. And Part 4 addresses the various forms of uncertainty regarding mortality data. Because it's one thing to just have a life table, it's another to actually start thinking about, well, where did the figures in this life table come from, and are they still relevant now? So, in more detail, Part 1, Chapter 1 just talks about the basics of insurance and the asymmetry of future lifetimes. Namely, that that lifetimes are negatively skewed, meaning that it's less surprising to live considerably shorter than the life expectancy than it is to live considerably longer than life expectancy. Chapter 2 talks about survival models and introduces the survival function and the hazard rate, which are probability functions that did not come up in Exam P. It also describes how and when to use what's called curtate functions. Those are functions that only look at the number of whole years that somebody survived. Chapter 3 goes into how to use and how to read a life table. If you've ever looked at a life table, it's got a whole lot of columns with these symbols that it's not immediately intuitive what they mean. Chapter 3 goes into all that. And then Chapter 4 talks about the math behind life insurance arrangements. And Chapter 5 talks about life annuities. In Part 2, Chapter 6 goes into how to determine the premium for insurance. That is, given, say, a $100,000 insurance policy, how much should the insurance company be charging as a premium every month in order for that to be a fair arrangement? And Chapter 7, so it shouldn't be at all surprising to you that you're more likely to die in a given year if you're older than if you're younger. What that means is that of the policies in force, assuming that it's a fixed amount, say $100,000 life insurance policy, and a fixed premium, that means that the insurance company is likely to be making money on average earlier in the policy and losing money on average later in the policy. Which means once you've had policies in force for a while, how do you make sure that the company has enough assets to cover its expected liabilities? Part 3 goes into, as I mentioned, more complex insurance arrangements. So Chapter 8 discusses multiple state models. What if you throw disability into the mix? So you're not just worried about alive or dead, but alive, disabled, or dead. Or what if the insurance policy is such that death due to one cause gets one payout and death due to another cause gets another payout? For example, if an employer has, as part of the benefit, a life insurance policy for all of its employees, and included in that life insurance policy is that there's a greater payout if death were in any way work-related. There you need to worry about different causes, right? It's no longer just alive or dead, but alive, died from work-related injuries, died from non-work-related causes. Chapter 9 discusses arrangements contingent upon multiple lives. Most commonly, that's if you have a married couple and they're retired, they'll both need an annuity to cover their future expenses. And so what happens, so if they're both alive, they'll need some amount of money for the two of them. If only one is alive, that one person would need less money, but more than half the amount of money, right? Because you look at two people married living together, some of their expenses will be on a per-person basis, like food and such. Others would not scale with the number of people, such as the mortgage or property tax or rent on your house. Chapter 10 goes into pension arrangements. And Chapter 12 goes into profit testing. That is, analyzing, did the insurance company meet its benchmarks and make as much, or did the insurance company make as much money as it really needed to, given its assumptions, right? Given what we call the basis, the set of assumptions regarding mortality and such, mortality interest. More about the details when we get into Chapter 12. Finally, in Part 4, we get into uncertainty in sampled mortality data. Right? So, if you want to know what's the probability that a 20-year-old will live to be 90, in theory, you'd need to take a large sample of people 20 years old and wait 70 years to see whether or not they'll live to 90. Which means it's tough to get reliable samples for that, and you can't update that very easily. So, if you only have a small sample and you're trying to say, well, what's the likelihood that these people live how long, there's going to be some uncertainty there. Then there's uncertainty in how mortality rates change over time. Typically, mortality rates improve, they go down, as improvements in medicine. If you look back in 1880, the United States life expectancy was about 40. Now it's around 80. These days, seems to have temporarily stalled out a little, in that life expectancy has been relatively constant, but with improvements in, say, diet science, or our knowledge about nutrition is a lot better than it was even 30 years ago. Would be at all surprising if, with better knowledge about nutrition, mortality rates drop even further in the next 30 years. And finally, there are some details about disability insurance that get covered on LTAM. So, with that overview of the topics out of the way, let's go over the basics behind the structure of this video course. So, I'll give chapter by chapter informal video lectures. They won't be, so unlike a classroom lecture where you know exactly how long it's going to be, some of these lectures might be longer or shorter than others. I'll segment them by chapter in the Dixon-Hardy-Waters text, and possibly segment them even further, some of the chapters I'll say, these topics should be mentioned together, and then I'll make a separate video for these other topics, but there will be at least one video per chapter. There will be some solved example problems, relatively simple solved example problems, just to show how to go about a concept. Or sometimes the example problem will be posed, and that will be used to teach, well, why do we care about this concept that I'm going to talk about? Often it's the problem that motivates the content. After that, there will be a recommended problem set. The recommended problem set will typically be the Society of Actuaries' official sample multiple choice problem set. And sometimes some of their longer written answer problems. Thing is, some of those written answer problems span multiple chapters. They'll have parts that go from one chapter and parts from another. So for the end of chapter exercises, those will mostly be multiple choice problems. You'll be expected to at least attempt the multiple choice problems on your own. I will present full solutions to those recommended problems, as well as providing full prosaic explanation. One pet peeve of mine is that the Society of Actuaries does not provide much of a prosaic explanation for a lot of the algebra they present. Oddly enough, if they're presenting something that relies on some prerequisite knowledge, say from exam P or something, they might go into a lot of the details and verbally explain everything from the prerequisite, but anything from the most recent topic, that they'll just say, yeah, here's the formula, or sometimes not even here's the formula, just say, yeah, here's some algebra, there are some numbers here, you should be able to figure out where the numbers come from. In contrast, I'll actually go through and say, now if the survival probability here is 98%, that's where there's a 0.98 over here and a 0.02 over there. So I will go through and fully explain the solutions. I may say, all right, that you set this up and then algebra happens and you'll get this result. No, trust you can do the algebra or even calculus. Right? I'll trust you can do that much on your own. But anything that deals with the actual content from those chapters, I will go through why stuff appears where it does. If a problem is particularly similar to earlier problems, and I've already presented solutions on those, I might say, yeah, it's another one of these, similar to these other problems, you just do this. I might say that, which is why I would recommend that you go through the problems in order. Each problem will assume that you know how to do the previous ones, but besides that, I'll go through a full explanation as to where the solution for each problem comes from. Now, I talked a bit about prerequisites. What prerequisites do I expect you to have in order to understand the material of this video course? I expect you to be fully familiar with Calculus 1 as well as the technique of integration by parts. Or at an absolute minimum, I expect you to be comfortable opening up your calculus textbook again and looking up how to do whatever calculus technique you have in mind. I also expect you to have a basic understanding of probability as covered on exam P. Now, what do I consider the basics of what's covered on exam P? All of the most common distributions, normal distribution, uniform distribution, exponential distribution, binomial distribution, Bernoulli distribution, all of those, I expect you to have committed to memory formulas for the probability density function, cumulative distribution function, although you could just integrate it for that, average or expected value, and variance. I do not expect you to have moment generating function committed to memory. Moment generating function almost never comes up on LTAM. In fact, I can't think of any cases off the top of my head where it ever comes up on LTAM. And on the rare occasion that it might come up, I won't expect you to remember it from back when you were doing Exam P. Other stuff I do expect you to remember from Exam P is knowing that the expectation of a sum is sum of expectations, that the variance of an independent sum is sum of variances, and I expect you to know the law of total variance. That comes up occasionally, law of total variance. So if you don't remember those, at least get comfortable looking them up again. Finally, for Exam FM, I just expect you to remember the basics of the theory of interest. Namely, if you're making level payments over the course of time, under a constant interest rate, why that gets you a geometric series, as well as how to sum a geometric series. Well, and I guess the integral equivalence of that, but I expect you to remember those absolute basics. I don't expect you to remember all the finer details from Exam FM, like how to conduct Reddington immunization or anything like that. That doesn't come up here anyway. But I do expect you to know how to sum a geometric series, why you would sum a geometric series, how to set up a cash flow equation, right? That if you're paying, say, 5 per year at the start of the year with a 5% interest rate, that would be 5 plus 5 over 1.05 plus 5 over 1.05 squared. I expect you to know that. Anyway, one last administrative detail is I'd like to talk about the educational style that I'll be using here. So I should mention, my bachelor's degree is actually in mechanical engineering, not actuarial science. And I've decided I'd like to present this course using the engineering school model of student development. Now, I don't know if you've ever heard anyone talk about student development or what that even means. I'll go into that now. So, often educators will talk about content versus student development or content versus processes. Content would be knowing the equations. So, for example, in a physics course, there's knowing that force equals mass times acceleration. And there's knowing that when it comes to friction, friction equals coefficient of friction times normal force. And if you were taking a high school physics class, typically, they would have their short list of formulas, and they would design their sample problems, or they design their problems based on each formula, and they'd say, all right, here's a formula, let's give you everything you need to know with one value missing, and ask you to solve for that one missing value. Once you start studying any sort of STEM field at the collegiate level, you're expected to do more than just remember a formula and figure out which one variable to solve for. You'll be expected to solve multi-step problems. So, for example, they might say, if I've got a block on top of another block, on top of an inclined plane at 20 degrees, how quickly would I have to push that bottom block in order to make the top block fall off of it, given the coefficients of friction between the two blocks and between the bottom block and the ramp. Now, this isn't a physics class, I won't go into exactly how to solve that, but you can see how there's a difference between that and if I force a block with this mass, what will its acceleration be? So, the ability to see a more complex problem and be able to break that down into how to use formulas that you've been given to solve for what you need given the problem statement, that is what I consider to be student development. And in the engineering school model of student development, relatively simple problems are presented as part of lecture. In these video lectures, I'll present single-step problems, and I'll solve single-step problems that you won't be expected to do on your own as part of a homework assignment. But when it does come to the homework assignments that you'll do at the end of each chapter, those will tend to be multi-step problems. You'll be expected to work through how to solve these problems given the single steps that I present in the video lectures without it first being explained or demonstrated how to string those together. You'll be expected to work through that on your own. Now, if you get stuck, I will have a full solution to each problem. And I would recommend that you go through and so try to solve the problem on your own. And if you get stuck, then watch the video solution until I mention whatever piece of information will get you unstuck, and then try to solve it on your own after that. I'll mention, you're not being graded on this. I'm going to presume that you're self-motivated enough to hold yourself accountable, both in terms of actually doing the problems and in terms of knowing when to try to work through something on your own versus when to look at my video solutions. But ultimately, you don't really learn math just by watching people talk about math. The video lectures are not, just watching my video lectures is not what's going to help you pass LTAM on its own. Watching the video lectures, then you working through the problems as best as you can, watching my solutions, making sure you can explain to yourself why my solution is correct, and possibly, if there's something you really don't understand, feel free to leave a question in the comment section on the YouTube video. That's what's going to help you pass the LTAM. So, with all of that administrative stuff finally out of the way, we can actually start talking about some of the material. And unfortunately, this chapter 1 has some of the most boring material. I hope you're not discouraged by my relative lack of enthusiasm over the material of this chapter. It's relatively light material. I'm more excitable about other content. Please don't interpret the tone in the duration of this video as a reflection on my thoughts on the course content overall. It's just, I consider this material here to be among the least interesting as far as this course goes. So, just some of the basics. What is life contingent insurance? It's a way of averting the financial risks associated with life or death. So, with death, right, there's life insurance. There is the financial liability of funeral expenses, and often life insurance contracts are priced to account for funeral expenses. But the larger issue is, what if there are people who financially depend on you? If those people were relying on you earning money that you're now not earning, because it's a little tough to earn money after you die, then you'll need some sort of risk aversion for that financial risk. Flip side is, when you retire, you are no longer earning an income from your job because you've retired, but you still do have expenses. And so how do you make sure you have income that can't be outlived? The answer there is annuities. Now, you might remember annuities from exam FM, where you think of an annuity as money that's payable every year. So, what does that have to do with life contingencies? Well, on exam FM, we dealt with what's called annuities certain. That is, money being paid out every year regardless for some fixed amount of time or sometimes a perpetuity. Here, we'll mostly be talking about life contingent annuities or whole life annuities. Those are annuities payable every year as long as you are alive. And so with an annuity arrangement, that's actually the most financially efficient way of making sure that you'll have money to fund your expenses as long as you're alive. Now, we talked about risk, right? Risk implies uncertainty. The main uncertainty here is how long a given person is going to live. And with any sort of agreement or contract, when there's uncertainty, one side will benefit from one kind of the uncertainty, and the other will benefit from the other side. So, in an insurance arrangement, if the policyholder lives longer, the policyholder is paying more in premiums, and the face value amount, say the $100,000 or whatever it is, that you're paying for insurance, or that you receive for insurance, that would be worth less real money the longer you live, because interest is a thing. So the longer you live, the more beneficial it is for the insurance company. Whereas for an annuity arrangement, the longer you live, the more time you're receiving money. So the longer you live, the more beneficial it is for the policyholder. Thus, an insurance company would want to evaluate your health before agreeing to a benefit structure or before agreeing to one of these. Sort of. As I'll discuss momentarily, they'll evaluate your health before signing a life insurance agreement, but generally not before signing an annuity arrangement. Because the uncertainty in future lifetime is heavily asymmetrical. Life expectancy in the United States is roughly 80 years. Suppose somebody lives 35 years less than that, dying at age 45. That's considered tragic, but plausible. In contrast, suppose somebody lives 35 years more than life expectancy, to 115. There are a remarkably small number of people in the world who currently have been verified to be at least 115 years old. So this would border on the implausible. So from a mathematical perspective, we'll say that lifetimes are negatively skewed. And so what this means, remember, the insurance company is worried about possibly losing a whole lot of money because of the health of the policyholder. For a life insurance arrangement, they might evaluate you, they might give you a checkup, and yeah, if they find that you have late-stage pancreatic cancer, suddenly what looks like a good insurance agreement on paper is no longer a good insurance agreement, because with near certainty they'll have to pay out the full amount very, very soon, hardly gaining any premiums. However, there's nothing that they're going to see that's going to indicate that you are particularly likely to live an awfully long time. So insurance companies will use underwriting for insurance, but not for annuities. This concludes the content of Chapter 1. There wasn't very much there. Normally, I would say, yeah, and then go through the Society of Actuaries multiple choice problems on this. Go ahead and go through those, I guess, if you want. There's like 2 questions, and they're both simple little conceptual questions. I will not be going through full solutions on them. And it's just 2 of them, and they're simple little conceptual ones. One of them is entirely about the whole not doing underwriting for annuities. But typically, I would assign a homework assignment now. That's what I'll be doing on future chapters. But that's it for now. Stay tuned for the Chapter 2 video coming out soon. And as always, if you like the way I explain things, feel free to click the link in the description below if you want to arrange private lessons. And until next time, this is Dr. Nighttime wishing you a good night.